Welcome to today's webinar. The topic today is construction stage analysis in RFEM 6. My name is Andreas Hörold. I am responsible for marketing and public relations in the company Dlubal Software. For instance, the website, the webinars, newsletters, and so on. I will be the moderator today and will answer your questions together with Bastian, but my two colleagues can introduce themselves.
Yeah, hello, my name is Adrian. I'm responsible at Dlubal Software Company for customer support and also for development. For customer support, especially regarding questions about concrete, and in development in RFEM 6, especially for the construction stages. And yeah, that's the reason why I present today's webinar.
Yeah, hello, my name is Bastian Kuhn. I have a similar job than Adrian. I work in customer support and in the development in the field of timber and buildings or building models.
Okay, thank you for your introduction. Then we can switch off our webcams that the attendees can see the full screen. I say something about how you can ask questions, at least for the attendees who participate the first time. You can show that panel on the right side of your screen with that arrow here, and then you can enter the question here and we will answer you. The other way is to watch the entire webinar and then email questions to info@dlubal.com. To the agenda today, Adrian will start with that model here, and he will start with defining the construction stages with regard to model, then with regard to loads. Then he will do the design and evaluate the results. Then he turned to another model and show the modification of design properties in the construction stages. And then he switched to a third model and he will show the consideration of plastic deformations from previous load situations. Okay, then I hand over the screen to Adrian.
So you should see my screen now.
Yes.
So then I will start with the, let's say with the main example of today's webinar. This is a mixed concrete timber structure with 8 stories. There's a concrete core with 30 centimeter thick walls. The slabs are in the 6th story are also made of concrete, 20 centimeter thick. The other slabs are made of CLT, 5-layered CLT, and there are here also timber columns which are quite slender. They have a quadrangle cross section with 20 centimeter aside. And the example should show the difference in the results, especially for the design of the timber columns. It should show the difference between a 3D structure without considering construction stages and the structure or the calculation including the consideration of construction stages. First, I will show the input of the construction stages, which consists mainly of 2 parts: the definition of the construction stages on structure side, so for the structural elements, and then the input for the loads or for the load side. First, I have to activate the construction stage analysis CSA add-on, which you find here in the base data add-on, like the other add-ons. And once I've activated the construction stages, you see that there are additional options for the input. And here in the navigator, you have the input for the construction stages for the, let's say, structure side. And I have to choose the elements which I would like to consider. So here in the example, for the first stage, members, surfaces, nodal supports, also line supports for the core. And then I have to choose which parts of the structure are activated for construction stage 1. And I have to define the construction stages here step by step. For the first stage, I have the nodal and the line supports. There are only supports in the first stage, and I could use this option to activate all because in the other stories or in the other stages there are no supports anymore. And then I can create another construction stage for the second story and do the same. I can activate members, surfaces, and so I have to do it for the whole input. I can also create all construction stages till the last story. So these are 8 construction stages. And then do the input for members and surfaces. The selection works in a way that you only could activate elements which are not activated in another construction stage. So if you see, if I select here a larger area, the program automatically recognizes that the other parts of the structure are still activated in a construction stage before. Yeah, there are also other possibilities for the input. You can do, of course, also a numerical input if you have the numbers. There's also the option to use, for example, our programmable interface to do the input, or the web service and programmer API and web service. This part was shown in one of our last webinars, which you find on our website. So there are different ways how to do it. Here, this is the way I show it now is quite classical way of doing the input. So now I have done the input for the members and surfaces. There are also line hinges in the structure between the slabs and the core, which I have to activate also for the construction stages. I choose here the line hinges, and then I have the additional register. And here I could also use the function to activate all line hinges, because the program automatically recognize which surfaces are active in this particular stage, and then it automatically activates only the line hinges which are applied to the surfaces which are active in this stage. This I have to do this for all construction stages. I could also use the multi-selection and say for all construction stages I activate the line hinges, and for all construction stages I say activate all, and the program automatically recognizes which line hinge could be activated due to the activated surfaces. So yeah, this is the input for the structure side. And if I have defined the construction stages, I can here switch to these construction stage elements or options here, and I see how the structure is activated. Yeah, and now I need the other part of the input, and that's the load side. So there's now clear which parts or which structure parts are active in the stages. Now I have to say, I have to choose which load cases or which loads are considered in the single construction stages. And therefore I go in the load cases and combinations. And as soon as construction stages add-on is active, you have an additional register here, construction stages. And here you have an input for the load cases, and you could choose which load cases are active in the single construction stages. And I activate in the first construction stage, activate the self-weight. The self-weight is automatically considered as a permanent load. This means it's once it's activated, it's considered for all following construction stages, and the program automatically considers the self-weight of new activated elements. So if I activate in construction stage 2 additional surfaces or additional slabs and columns, then the program automatically recognizes this additional self-weight which is applied in the construction stages. In this example, the important thing is to consider the distribution of the self-weight correctly during the due to the construction process. The design I would like to do then for the finished structure, and therefore I activate the temporary loads only for, in this example, only for the last construction stage. And yeah, then I could, based on this construction stage, I could activate the combinatorics or do the combinatorics and design the structure for the last construction stage. But I have the real distribution of the self-weight due to the construction process. I switch back here to the main register. And maybe tell a little bit about the options. There are here. You could choose the types of analysis. At the moment, there's still only the load combinations available, which means it's a method which considers the construction stages based on load combinations and based on a nonlinear calculation. So you could consider also all nonlinear effects in a structure. The, let's say, more simple method is not ready yet. This will be a linear calculation, which works based on some linear superposition, and this will later be an alternative, but will be only possible for a linear calculation. So the calculation itself will be a bit faster, but it could not be used in every case. Yeah, but with the current option, you could, yeah, the current option could be used for all cases. To activate or to consider the combinatorics for the last construction stage, I can here activate the combination wizard, and I have to open the details and say consider construction stages only. And as soon as I have activated this option, the combinations or combinatoric is done for the last construction stage. Yeah, and if I switch to action combination, the action combinations are created automatically. And here you see that there's already the construction stage 8 related. And then I could create the load combinations based on these action combinations, and the load combinations are of course also done for the last construction stage. Of course, I could also do the combinatorics for several construction stages. We will see it later in a smaller example. And I'm also able to do manually combinatorics. Then I have to choose these options, which combination follows, or I have to choose how the combinations follow each other. So what's the first stage, second stage, and I have to choose which construction stage is considered and which result is considered from previous stage. Here, in this case, if I use automatic combinations, the program does everything automatically, and I have here my ULS combinations and quasi-permanent combinations, and I also have here some additional, let's say, auxiliary combinations because the program considers the factorized permanent load. So normally, if I do not use the combinatorics combinations, the stages are calculated with 1.0 factorized permanent load. But as soon as I activate combinatorics and I have, for example, here 1.35 factorized permanent load, the program generates for the single construction stages. So for 1, 2, 3, and so on, it creates auxiliary combinations to have the factorized results with the permanent load. But they are, yeah, let's say for more for internal use. The design is then, of course, based on the combinations which are related to a design situation. Okay, then I switch back here, and I could now switch to the timber design. Regarding the design, everything the input is done. There's no special input related to the construction stages. As soon as I consider the construction stages in the for the load combinations, the design automatically is also considering the construction stages. So I can calculate the design. Before the design is done, the internal forces have to be calculated. And first of all, the construction stages have to be calculated, and this is only possible step by step. There could be only one combination calculated if it is based on construction stages. But as soon as I have these common combinations, the calculation is possible parallelly. So here we see these are all these combinations are related to the last construction stage, and the program is able to calculate them at the same time. But for the construction stages, like construction stage 3 needs the result of construction stage 2, so there is no calculation of different construction stages at the same time. That's mathematically not possible. And then the design is done, and I have results for the design. Here I only designed the timber columns to take a look at the design ratio, at the stability design, and to compare it with the structure where no construction stages are used. So I have here this original structure. I can show it in 2 windows like this. Okay, now it's on the left side, but it does not matter. Here's the stages result. Maybe we can show it in this way, and here is the result without stages calculation. We see that here there's the design is nearly fulfilled. Probably we would say it's okay. It's only 1% too much. So this is probably something which would be okay. But if I consider the construction stages, I see here that there are nearly that we are nearly 10% too high. And the reason for this is that there's is the let's say the distribution of the normal force in the columns. So if I take a look at this column row here, I only make this part visible. So like this, and show the deformations. Like this. One moment. Like this. And take a look here at the deformations, and I do the same for the structure without construction stages. Maybe I activate first the statistical analysis. It show the deformation here, here, and I compare the deformation between the two structures. I see that in the first stories, or the first, second, and also third story, deformation is compared to each other is quite similar. Maybe I switch to a load combination where only self-rate is activated. Then it's a bit more clear. Yet my visibility is gone here. This. Then it's a little bit more clear, because the main influence is comes from the self-rate. So it's quite similar, the deformation in the first stories, but then as higher I get, as more difference is in the deformation. And the reason is that the deformation in the considering the construction stages, the deformation is balanced during construction process, and in the structure where I do not consider the construction stages, the let's say the deformations are some kind of summed up here and not balanced during construction process. This effect is not considered. So this means there's also related to this effect, or to this deformations, the columns here get not so big normal forces. The normal forces are distributed to the columns around here, and if I look at the normal forces, I see also that there's a difference. I switch it here, and only show this column here and here. And I see that there's a difference. So this of course leads then to a different design ratio. And as I said, the reason is that the construction stages, considering that if I create a structure step by step, the deformations which occurred during self-rate, they are balanced during the construction process. But here in the structure without construction stages, this is not considered. So there's some kind of summed up deformations, and then the columns in the higher stories do not get that much normal force because they are deformed, and then the normal forces are distributed to columns around this column. Yeah. So this is the reason, and here we see the of course the influence of considering construction stages. So that's not that small. It's the governing column with quite, let's say about 8 or 9% difference in for the design. The influence of construction stages is especially if you have different stiffness distribution. So like you have a concrete core with high stiffness, and then you have slender columns. This is quite typical that the construction stages have a high influence, and also here with these columns, there's a quite high influence. Yeah, so this should be the main example which shows the influence here for the column design. I would like to show also another situation for this structure, but I already calculated it because calculation needs about, let's say something about 2 minutes. It's a bit too long to show it in the webinar. It's some kind of let's say new feature. It's now possible to calculate based on the construction stages the correct state or the deformation in correct state according to the analytical method. So this means that this was not possible before. So if you have use RFEM 6, you should use, I would say, the version 6.04, then this feature should be available. Based on a construction stage, and while doing the concrete design, you are now able to calculate the deformation in correct state, but only for a particular construction stage. So it's the analytical method. You could calculate, for example, in this case, you have a final stage, the structure is completed, and then you could calculate the deformation in correct state. It's also possible in an earlier construction stage, but what's not possible at the moment is to consider the cracking during the construction stages. So from one construction stage to another, this is not possible, but this will be also possible in the future, but then in combination with the nonlinear concrete calculation. This here is the analytical calculation. And here we see also that there's some kind of an influence. On the left side is the stages example. On the right side is the example without consideration of construction stages, and you see here that there's also some kind of an effect which where the deformation increases over the stories, especially here these upper 3 stories, and this deformation here is also let's say balanced, or there's also some balancing of the deformations during the construction process. So there's also, it's not that large, but there's an influence in the results. This is something I would like to show or to mention because it's quite new that it is possible to calculate the deformation in correct state for a particular construction stage. I now switch back to another example where I also would like to show something which is new in the program. I prepared an example regarding design properties, which could be now changed during the construction process or with the construction stages. So, so I'm able to adapt, let's say, the input or properties which are related to the design in the construction stages. So this is a smaller example. Yeah, let's imagine this. The steel structure is attached to an existing building here, and but due to a let's say temporary construction, we will remove this supporting here or this elements in the middle, and would like to check if the structure still works. So I have to start like I did before. I have to activate the construction stages and do the input. This should be quite fast because I have a complete existing structure, so I can activate members and nodal supports and say everything is active for the members and for the nodal supports. And then I have a second stage where I would like to deactivate 2 members. So this is, let's say, this supporting part here in the middle. And then I would like to check if this still works. I have to, of course, assign the loads to the construction stages. So the first part is maybe the original structure, maybe this, let's call it, yeah, construction. And I assign the loads here, like I also did in the example before, but here in the first stage, I have like a complete structure. Everything should be considered, the self-weight, dead load, live load, and wind loads. And then for this, let's say, temporary construction stage, I only want to consider the permanent load, which is already active because it's permanent, and the wind loads. But I would like not to consider the live load because it's some kind of construction process. So this is the load side. Here I would like to create combinations for both situations because I would like to design the original situation and the construction or the situation for the construction. So I activate both for both construction stages. I activate the combination wizard. If I take here a look, I also that's something I prepared. I also activated the stability analysis for this combination wizard. So this means for all load combinations, there is also done a stability analysis, and eigenvalues are calculated and eigenshapes. So I switch to the action combination. I check if there are action combinations for construction stage 1 and 2. Both are available. And I go to the load combinations, and here I have load combinations for construction stage 1. This is from load combination 1 to 10. These are load combinations for construction stage 1, and 11 until 14 are the combinations for the construction stage 2, which is the where the structures under construction. And as I see here, there's for all load cases, there's activated the stability analysis. So now I calculate all combinations, and then I will have a look at the results, especially I will have a look at the stability analysis. to have a look at the eigenvalues or eigen shapes. So I switch here. Maybe first one I switch firstly to the stability analysis. And then I choose some of the, let's say, governing combinations of construction stage 1. I did a look before it, so I know that it is that I could use combination 9 or 10 to show it. And then I switched between the critical load factors or the eigen shapes to have a look how the column behaves. And the third here in the third eigen value, I see that it is that I have here this two-wave shape for this column. But when I remove, or during the construction stages, there's removed this this part here of the structure. So also this shape will change, or will probably change. I take a look at combination from construction stage 2. So for example, combination 14, and also switch between the load factors here, or between the eigen shapes, and I see here how it changed. This changes. This part is now for the construction stage 2 inactive. So it's changing from a two-wave shape to a one-wave shape. And this is something I would like to consider for the steel design. And this is the part which is new. I've created two effective lengths. The original situation, this two-wave effective length, so where I have a buckling length of 4 meters. So one story high is here 4 meters, and then I change it for the one-wave situation without an intermediate support, so that the effective length or the buckling length is here 8 meters. And now I have to choose for the construction stages in which construction stage which effective length could be or should be considered. So I switch back to the construction stages input, to construction stage 2, and to the members. And in construction stage 2, I would like to change this effective length from this buckling length 4 meters or two-wave wave shape to this one-wave shape, the buckling length 8 meters. So I choose the 4 columns where I would like to consider and say property to modify. And here I could, this is new, these options, and I could here change the effective length. And the program automatically knows what the original value is. And I say the new value should be the effective length, which is one-waved. And I say apply, and OK. And then I could do the steel design and have a look at the results or at the design details if it considers now the also the effective length differently for the construction stages. So I have to recalculate. And then I could have a look at the steel design. So as soon as I have construction stages active for the design add-ons, you always get this additional, let's say additional register or additional table where you have the results of the design or the design ratios based on the construction stages. So here there's the governing results for construction stage 1 and here for construction stage 2. For construction stage 1, there's here the stability analysis. And if I click to or if I have a look at the details of the design, I see here the buckling length is considered with 4 meters. This was the original situation. And for construction stage 2, there's here the stability design, which is a bit higher because the effective length or buckling length is higher. The load is smaller, but yeah, that's exactly what I would like to check in this example. And if I take a look at the design details, I see here buckling length is considered now correctly for construction stage 2 with 8 meters. So this is, yeah, this is the thing I would like to consider, and this is now possible that I am able to change or to consider different design properties in the single construction stage or in the different construction stages. I switch back again to the options here. So these parts are new, and of course they are also available. They are not only available for steel design, they are also available for concrete and for timber design, but it depends on which add-ons are activated. Here in this example, only steel design is activated, and these are the design properties which I could modify. I could, for example, also say for construction stage 1, there's a different ultimate configuration than for construction stage 2. So there are different possibilities. Yeah, this is something which is new in the program. Yeah. So this was this example regarding the design properties. There's a last very small example regarding the topic load history, because there were some questions in the past from customers. So I decided to show it in the webinar also on a very simple example. So yeah, as I said, we received some requests about the add-on load history, which was available in RFEM 5, but is not available anymore in RFEM 6. And the reason for this is that in RFEM 6, the construction stages could do the same like the load history in RFEM 5 was able to do. So we could here, I choose this, let's say it's quite theoretical example, and a steel beam or simple beam, but in this case made of surfaces, but it should work the same for a member, where I assigned plastic material or material with plastic behavior, and the example should show that I could apply a load to this structure, and a load which also causes plastic deformation, and then I will remove this load. This could be done with applying the load vice versa. So I remove this load, but there will be still some the plastic part of the deformation. This will remain in the structure. This could be also done with the construction stages. So it's quite simple. There's no combinatorics or something. I only choose for construction stage 1, there's load case 1, and for construction stage 2, I add load case 2 to remove this load. And if I calculate construction stage 1, that's of course now with nonlinear material behavior. I get a deformation, and there's some plastic part in the deformation, or that's maybe can show it. That's here. There's some plastic behavior, and I get a deformation. Let's say maybe it's 63 millimeter, and then I add the load in the second stage. which removes the load which is already applied. But the due to this plastic behavior, there remains part of the deformation. This is the let's say plastic part. So the deformation is not completely removed, like it would be the case if you have linear material behavior, or if you have a load which is not that large that it causes plastic deformation. So this is something I would like to show at the end, because there was the question, and it's quite easy to show it on a simple example that this is also possible in constructed stages in RFEM 6, and there's no, let's say, no need to have a load history add-on, because everything which could be done in load history is also possible to be done in RFEM 6 in construction stages. Yeah, so this was this should be these 3 examples. Yeah, so that's all. So I can switch back to Andreas. And
okay, Adrian.
Yeah.
Thank you for your presentation, that you showed the current state of the program or the add-on construction stages on these 3 examples. Before, I would like to show you where you can download the examples and find the recording in the next days. I would like to show you or give you a hint. If you want to book your free online appointment, such as a product demonstration or something like that, or you would like to get a non-binding offer for any product of Dlubal Software, then just contact our sales team with that link here, or you can scan the QR code. You will find the presentation slides on the website. I will show the website, dlubal.com. Under News and Events, you will find the webinars. That's today's webinar. Those are the webinars of the next week. That's also a new feature, seismic design on reinforced concrete structures. Then there's a new add-on, time history analysis. That's the webinar in 2 weeks. Yeah, just register, or you can wait for the invitation, or I think we already sent out the invitation, at least for this webinar, if you are registered for our newsletter. So let's click on the webinar of today. In the next days, you will get an email with a direct link to that page. Then you will find the recording in the middle here. You already find the presentation slides of the webinar, and if you scroll down, you can find all 3 models that Adrian presented today. Okay, that's also all from my side. Thank you for your attention. Thanks to Adrian for the nice presentation. Thanks to Bastian for the help by answering the questions. I wish all a nice rest of the day, and bye-bye.
Bye.